So I just committed the code to the GitHub repository, so you should be able to check it out with new rule variations. But the problem was that, well, we will get a lot of more new variations for these types of rules. So any ideas on how to solve this? Well, we could, of course, try to use the same approach as we did. Have the dealer class and just do abstract operations for this, use polymorphism, and implement different variations in subclasses. So in this case, we would kind of like have the class for European dealer, not soft 17 dealer advantage. And we would have American dealer, not soft 17 dealer advantage. European dealer, soft 17 dealer advantage, and so on and so forth. So we will have a lot of new combinations. And if we have 2 rules and 2 variations, we will need to implement 4 classes. If we have 3 types of rules with 2 variations, we would need to implement 8 combinations. If we can imagine 3 types of rules with 3 variations, 27 subclasses, and if we have 4 variations, we will have 81 combinations. That's a lot of subclasses, and you can just imagine the code duplication issues between these, and just trying to find the right one here is not that easy. So this is, of course, nothing that we want. However, there is, of course, a pattern for this type of situation also. How can we encapsulate an algorithm and make specific implementations interchangeable? This is what the strategy pattern does. And the idea is then to encapsulate the algorithm in an interface, let algorithm variation realize the interface, let clients depend on the interface and be composed with specific implementations as needed. So instead of using inheritance and different types of dealer, we should encapsulate the algorithm in itself in an interface. And we should plug this into the dealer to let it work with different rules. So it kind of like looks like this in the abstract way. So we have this algorithm strategy with the operation for the algorithm. We have concrete implementations, concrete algorithm B and concrete algorithm A, and we have a client that kind of like used this algorithm instead of being directly dependent on the exact type of variations that we will have. So in our case, which class is the client? Yeah. View, no. Which class will use this interface? Which class will the dealer, exactly. The dealer is the client. The dealer is the one that tries to start a new game in 2 different ways. So the concrete algorithm in the first case will be the American way to start a new game. The other concrete algorithm will be the European way to start a new game. And the interface will be kind of like, okay, start new game strategy. And we will take this and plug it into the dealer, and it can use it in its start game operation instead. So let's take a look at an implementation. It will probably be more clear. At least I hope so. So This should, of course, be stuff in the model. Game rules, so it will be stuff in the model. And I will even make a new package called rules and put it here. And we will create our new interface. And we said it should be named start. Well, maybe just I also. I like that. Start new game strategy. I think it's good to use the pattern name in the class name or in the interface name in this case, because it gives a direct pointer to what kind of thinking is behind this design, even in the implementation. So that is something that you can think about. So we will have two different variations here, and I think we could kind of like copy this more or less from these parts. But we will rename them. All right. Let's try and open it. Open. Oop, no, that was not it. Was even start new game. Start new game strategy. Good. So something like that. And now actually the tricky part. The tricky part is to find the interface that we need. To construct this interface in a good way, such a good way as possible to allow for different types of rule variations. And this is not something that is super duper easy, but we do have some code to look at before to try to construct this interface. Because we need to remember now that this is not a dealer anymore. This is just the algorithm for starting the new game. So we need access to some things. So we need to kind of like, okay, we need the player object. We need to have the deck. We need to do some stuff with the deck. We need to take a card and remove a card and stuff like that. So the dealer won't be abstract anymore. It will actually have some code in here. this is definitely needed. We need the player. That is absolutely necessary. And we also kind of like need the dealer, because we need to deal the cars to both the dealer and the player in the algorithm. So let's do it. And we can actually use the dealer as just another type of player in this case. And we also need the deck to get the cars from. So possibly this will be the interface that we need. So let's take some code here first and put it back in the dealer. And let's take the interface and do something like that. And this if statement is not really needed anymore. So instead of a deck, instead of M deck, we have a deck, a player, a deck. Possibly that will work. And we have basically the same for the American version. Except that the dealer should get a second card. That is hidden. Could this be it? So, all right, let's just add some test code here. So, odds of this compiling without any problem? Very low. Package does not exist. Do we need to do this? Cannot find symbol. Yeah, okay. Ooh. I think we should not do an American dealer here anymore because European and American dealer are classes that are not used. This is almost too good to be true, so let's see what happens. Something must be incredibly wrong. And we got the American version of the starting the game. Quit. We changed some code here. Maybe we should just do it like this. And we got the European version because we switched what type of object was actually created. So, all right, seems to be working at least. So this is good. The next step of the problem, so to speak, is to, well, is this a good idea? We can think about that a little bit. And we will return to the class diagram to add this new part of the application. So we should find a package, rules, and we have right, we have an interface. Do you have interface here? I think we have interface like this. Ooh. I start new game strategy. Something like this, all right, and we have two implementations of this. American new game strategy. Strategy. Yeah. Something like this. Anything more we should add? Is this it? We can take a look at the code. Let's take a look at the interface to start with. We have this, a player, and a deck. So these should be added, oops, as dependencies from the interface to the player and the deck. Things will now start to become a little bit messy. So the layout of this is not optimal, but that's not the point right now either. All right, if we take a look in the concrete classes, for that implements this. We can also see that they use a card as a local variable. We get a card from the deck, we show it, and we give it to the player. And this is something that we also need to show. We have a dependency. From each of these to the card class right now. And you start maybe to see that you seldom see a complete class diagram over a whole application. We kind of like have 10 classes or something like that, and it's starting to become quite messy. So this is why you seldom see big class diagrams over whole applications. I think that's about it. So, but we could also see that in our structure of the pattern, we had the client, and the client was in some way dependent on the interface, as it should be. And in our case, the client was the dealer. So something has also happened in the dealer that needs to be taken care of. And we can take a look at the code, dealer, and we have this right now. So we have a local variable of type I start new game strategy. This seems to should be modeled as a dependency to this interface. But we also have actually the concrete call to the constructor of the Euro new game strategy in this case. So this should also, of course, be modeled if we are to be really careful. And wasn't kind of like this the whole purpose of the class, of the pattern? To avoid, oops, wrong presentation. To avoid the client becoming directly coupled to the concrete implementation. Let clients depend on the interface and not on the concrete implementation of the algorithms. So creating the type of rule inside the dealer suddenly kind of like defeats the whole idea of having the dealer independent of this type of rule, on the specific type of rule that we need. So how should we do this? How should we avoid this coupling? So exactly, we have the answer in the chat. Send it in as an argument. And as an argument to what? We can't do this. This is forbidden. This is actually something of a problem because it's so easy to do these kinds of mistakes. You kind of like do this grand design of something, but then you make a silly mistake and just kind of like it defeats the whole purpose of the design. So, but we should not do this. It needs to be done somewhere else. But how should we do this? To what part of the application should we send it as an argument? We could add it here. So the one that calls the start new game is also responsible for actually supplying the rule. In our case, it would mean that the controller would need to create this type of class. That could be a good idea if the user actually had a choice of the rule. In our case, the user has no choice, and this would add a responsibility to the controller that it maybe does not really need right now. This seems to be a part of the program where stuff is created and actually composed, and then you run the game. So I would argue that we would need to create this rule here instead. So instead of having this in the dealer, we add it to the program class for now. And we send it as an argument to the constructor. So it's more something like this. Yeah, these will be removed anyway, so let's just comment it out for now, maybe. Oops. We got the European version. Quit. Did I quit? Quit. And we got the American version. So this seems to work. And we have removed the bad dependency from the dealer to the concrete implementation of the algorithms to start a new game. And this is good, because then we can remove this. This I would like to delete it. So, all right. This is how things look right now. Let's remove these. Really? Yes, really. Really, really. Really, really, really. All right, so strategy pattern. Encapsulate the algorithm. Let the client depend on the interface of the algorithm. Let someone else create the concrete types of algorithms the client is to use, and plug it into the client in some way. And what do we get? We get parameterization of client object. For example, using dependency injection. And this is just a fancy name of saying we can send parameters to the constructor of an object. Yay! So I don't really know why they call it dependency injection, because it's kind of like something that has been done for ages. But new names for basic stuff is maybe something that is good. It favors composition over inheritance. So instead of inheriting and getting this explosion of classes that we need to implement, we can compose different types of dealers instead by having these three interfaces with their implementations. And if we have three interfaces, three types of rules with two types of variations, we only need to implement 6 classes compared to 8 classes. And if we invent 3 variations, well, then we need to implement 9 in our design versus 27 if we use inheritance. And if we invent 3 rules with 4 variations, well, it's 3 times 4, so 12 instead of 81. So composition in this case is really, really powerful. So we can have this, instead of using inheritance to create different combinations of rules, we can use composition instead. We can take these small parts, put them together, and give them to the dealer, and it will work. And this is something that you will practice also during the 3rd workshop, implementing rule variations for the other 2 types of variations that we have in the game. So you will practice this more. The problem can be who creates the concrete strategy objects, who should be responsible for creating this. And you need to take care so that you don't add this inside the client. It's a common mistake. In our case, we moved this all the way to the program class that will kind of like compose the dealer, and this is the dealer object, and then it will have the responsibilities needed. You, of course, get more classes interfaces. Good, bad, bad, good. Well, the design certainly got more complex. More arrows, of course. Maybe also when we did the inheritance, I did not add the card dependency from American and European, and we did not add the dependency to player. So I think that design would probably have at least the same amount of couplings, and you could just imagine doing this with 81 types of classes also. It would be really, really messy. But the design of this interface, the design here is often tricky. It's often really, really hard to do in a good way, to allow for the variations that you need. So this is something that is hard to do, especially if you kind of like just do this without having any concrete examples as we did. We had code for both of these variations, and we could use this code to kind of like find the common denominator, so to speak. And this is not something that is easily done in advance. You need in-depth knowledge about the problem. So hard to construct good interfaces. And sometimes you get these circular dependencies. And circular dependencies are not good. In some programming languages, they are impossible to implement. The compiler or interpreter cannot really work with these kinds of dependencies, because this class needs to be defined before I can compile this other class, but that class also needs to have the other class defined before I can kind of like compile myself, so it won't work. That is, of course, a problem. If the system can't compile or work, well, you can't have a design like that. Other types of programming languages can handle these dependencies, but having this codependence is of course not something that we would like, because it kind of like defeats the idea of having couplings that are as loose as possible, and having stuff not as dependent as they should be. And if we have a circular dependency, it kind of like tells us that maybe these two parts are actually the same part. So in our case, we could run into this problem if I kind of like just did it, but it could be instead of having a player object here to represent the dealer, which is perfectly fine because we are only using operations that exist in the player abstraction to deal cards. You could send a dealer in here instead, dealer, and maybe get rid of this argument and get the deck from the dealer instead, or do some other type of exciting operation. And this would create a circular dependency because maybe we should take a look at it. Because we have this dependency from the relationship from the dealer to the interface, and then we would get a dependency from the interface to the dealer. So then we would have this circular dependency structure, and that is not something that we want. And actually, this is not a dependency anymore. It's actually an association. So maybe we should update this. So it's like that. So and this is not something that we want in our design. If we get these circular dependencies, we should try to avoid them. And the idea is to have to try to start to have the not associations, at least in circular ways. I think if we have like inheritance, it will explode in any kind of programming language, because then I would be my own father in some respect, and that's never good. It won't work. The other way around is, well, we have a association from dealer here, and in this case we can't have association because it's an interface. But if we have association between circular dependencies using associations, that is bad, because then we can run into these programming languages that can't handle this. If we have association and dependency in a circle, that's a little bit better, because then it's just a reference to in one of the directions. But it's still not favorable, at least. So if we can avoid it, we should avoid it. And in our case also, it shows something else, that, well, we could send a dealer object in here. But then the guy that implements this has a larger interface than needed. He has a dealer object, and he can do all kinds of different stuffs that he should not be able to do. It's not part of the algorithm of dealing cards to start the game. But he could call, for example, hit for some odd reason. Or he could call stand. So opening up in stuff that's not needed is never a good thing. So giving the guy that's supposed to implement this too many options, too many functions that he needs to understand in order to do his to implement the responsibility is not a good thing. So sending kind of like, oh, here you have the great object to do anything. Just use it. That's not a good idea, because mistakes will happen. And, well, why did you call stand here? Well, I thought it would do the job. I could, so I did. And sending to two player objects, we don't really have that many options because the player is a lot more narrow. It has less functionality in it. All right. So that is also one kind of like principle to try to abide by, that you should not send overly large interfaces. You should not do overly large interfaces because it will just open up your system for making mistakes. So, oops, time flies. It really does. I could rant about this forever. We don't really have any more time today, but tomorrow we will talk about factory, abstract factory, and factory method, and we will also implement this in the blackjack game. So, any questions? No? All right. Then the rant of today is over. Thank you.